Today's topic will be Polished Concrete and LEED 2012, presented by Paul Nutcher of Green Apple Group and Greg Schwietz, President of L&M Construction Chemicals. Paul Nutcher, CSI CDT, is President of Green Apple Group. He has nearly 10 years of building industry experience as a marketing and sustainability consultant to building product manufacturers. Greg Schwietz, CSI CDT, is President of L&M Construction Chemicals, which produces chemical treatments for concrete construction, repair, and protection. He has been a member of CSI for 35 years and continues to support his company's involvement in CSI on a national, regional, and local level. This session will continue our explanation of soon-to-be-released LEED 2012 and its many new facets relevant to designers and specification consultants. Today's focus will be indoor environmental quality, low-emitting materials, flooring systems, specifically polished concrete.
To learn about the sustainable attributes of polished concrete from a materials and performance and sustainability standpoint. We're going to review the role of polished concrete when we work with a thermally active structure, which is using the benefit of a bare concrete floor to heat or cool the building. Third item, understand why buildings are more sustainable relative to the installation of a polished concrete floor due to the ingredients in the process. And fourth, to gain insights into the positive effect polished concrete can have on the long-term performance of the floor and the low maintenance and green maintenance features of this particular product. Next. Okay, so a few shots of polished concrete. Polished concrete, by the way, is relatively new in the industry. I'm going to say it's been most active for these past 10 years, and really for the past 6 or 7, it's really taken on a lot of attention, especially on new and existing new floors nowadays. Initially, it wasn't thought to be primarily a renovation type of a process. And then with the advent of colors and the proper procedures of coloring concrete and the decorative effects of exposed aggregate, etc., we've really added a lot of dimensions to what floors can do now on basic concrete floors. So renovation and rehab, new construction, dust-proofing concrete surfaces, the treatments leave a concrete floor that's very easy to maintain by adding surface durability, improving the appearance, and long-term maintenance benefits. Next. Okay, Paul. Sections that we're going to recommend or refer to, there is a polished concrete floor section at 033510. There's some related sections that relate to polished concrete because of both in the maintenance, the long-term part of it, as well as the placement of concrete that becomes important, and fillers. Next. And some of the physical property changes in concrete that have been polished, in addition to being smooth, which is an aesthetical appearance, visual appearance from the polishing itself, the concrete is also changed in its physical properties relative to abrasion resistance, its reflectivity, waterproof properties, and high traction, which is a critical factor in a lot of circumstances where we have a lot of pedestrian traffic, etc. Next. Elements of the polished concrete floor. These are things that we'll talk about in just a few minutes. So we're going to talk about where these slabs are typically polished at, what the near surface wear zone is, how do we treat the surface of the concrete in addition to the polishing process, and then how to maintain them. Next. Okay, with new construction, we must understand that we're polishing something that's being provided by another trade. And so typically a polish contractor is a subcontractor to the general contractor, different in most times than the concrete placement contractor. So in the physical properties of the concrete, in order to provide a good foundation and a good base to polish, we're going to recommend a couple of things to to the concrete itself, the concrete mix design. So minimum compressive strength should be 3,500 psi. That's 28-day strengths. Normal weight concrete, on some types we have, some floors, because we're doing multi-level projects, we use lightweight aggregates, and that will take some particular attention, but not normally recommended. Non-air and trained concrete, which is a typical interior concrete slab, which is what most of these jobs are. And finally, the placement properties is a normal mix as far as placement mixes.
On that slide, would it be 3,500 psi?
3,500, yes. Is an overall FF of 50, which requires a pretty good contractor to get you a good flat floor, and a local FF of 40. That's the flatness requirement. There aren't really requirements for leveling except on a specific project-by-project basis. But in general, it's the flatness measurement that is the most commonly recommended. Finally, the hard steel trowel finish without burnishing marks, a Class 5 floor, is a typical finish. And this, again, is on the fresh concrete placement to provide a good, strong base for which to polish. Thank you. Next, Mark. Paul. Okay, the installation of the a polished concrete floor. First of all, in the placement of the concrete, most typically the concrete is poured out on a new slab, and we want to maintain, in most typical applications, the polishing doesn't take place until after 28 days or longer. On some certain circumstances, they might polish earlier in order to, say, expose more aggregate, and sometimes there's something of that nature. But essentially, we wait to 28 days or longer before they actually do the polishing. Different aggregate appearances can be used to improve the aesthetical design. Lightweight aggregates not recommended because of their porosity, but if an exposed aggregate concrete surface is desired, then there are placement techniques of the fresh concrete that must be observed. The concrete contractor should be fully informed of this. And then in some cases, there's an actual seeding or placement of aggregate to create a uniform effect. Then finally, there's some regional variations relative to the quote-unquote hardness of the concrete. The hardness of the concrete is going to be due to primarily the finishing, which is why we recommend the hard trowel finish. If it's a real porous concrete, it's going to be difficult to develop a polish. And also in some areas, regionally, some aggregates are stronger or harder than others. And so some technique is necessary and experience is necessary from the contractor, the installing contractor, to provide the best, most uniform result. Next. Selecting an installer. When we started working with installers, the equipment that we had to use looks a lot like terrazzo grinding equipment, and it has advanced significantly, both the equipment and the diamond opportunities or options for these guys. And so in most cases, installing contractors, polished concrete contractors, are trained or informed depending on our experience. And so there's a number of ways that they gain their experience. Some of them do it the hard way, job by job. Some of them go through training, such as item number 3, CPA, which is the Concrete Polishing Association of America, has a 3-day course that teaches concepts of the proper way to polish, full refinement, uniformity, how to install chemical hardeners, things of that nature. And then finally, we do our own particular, I say the vendor, in our case, we have a special training that we give to our approved installers to know how to install the chemical treatment, when to install them, and how to protect the concrete. So it's a combination of working with reliable people with the proper equipment. We quantify and we tell them what type of equipment they should be using, as well as try to install or inform them as to proper installation techniques. But we do rely a lot on the independent organization, CPAA, to do the bulk of the training. Next. There's different types of chemical hardeners that are available that are treatments. I want to tell you that the polishing step is a very labor-intensive process. And so to polish concrete requires quite a bit of energy relative to equipment investment, personnel investment. And during the steps, which could be many steps, where they start with what they call ground zero or floor, depending on its condition and circumstances, they will grind through the floor and start with coarse diamonds and then proceed through a series of finer and finer and finer diamonds until they come to a final result where the floor is very smooth and takes on a shine that is very attractive. And so during that process of smoothing the floor, there's a lot of I'm going to call it damage that's being done to the concrete, because the removal of the hardened cement paste that's been placed there through the hard trowel finish, which also improves durability, much of that is removed in the process of smoothing the concrete and polishing it. So the criticalness of the installation of the chemical hardener becomes very important. And so largely your chemical companies are concerned about that part of the process, about when and what to use to harden the floors. We have found through our testing that the floor is significantly compromised relative to the surface durability, even though it looks very shiny and sealed. It is very weak. So chemical hardeners are applied densifiers that leave no film, that react with soft components in the concrete, and first coat restores the original durability from what we've seen, and then a second coat is necessary to really, and can be used to further improve the durability. We think that this is a low-cost addition to the cost of the polishing steps and provides a long-term solution relative to the investment of the overall process. So while it is maybe 10% of the cost of the entire floor process, it significantly adds to the durability and long-term life of it. There's two types of chemicals that are used most commonly. Some of them work very similarly. Alkaline silicates are used very commonly. They are scrubbed into the concrete. They're odorless, VOC-free. They're removed. The excess is removed. Whatever is not absorbed or saturated in the concrete is removed and disposed of properly. And then a lithium silicate, similar type of process, odorless, no VOCs, sprayed on, can be washed and removed, or can be allowed to dry, and it continues the process. So both are used throughout the floor and are used to densify and make the floor more durable. Okay, Paul. So water is used in this process, and of course water is used in the concrete mix. We need water in a concrete, and there is no particular concern about that. We are using normal concrete mixes. During the curing, water may be used to allow the concrete to cure out without leaving a film. It's used during polishing sometimes. Many of the polishing steps are done dry nowadays, but some are done wet, depending on the hardness of the concrete and a particular step. So that may be a consideration, but it's not mandatory. Finally, for maintenance, of course, this becomes a real saver for the owner, because of the maintenance is typically just the soap and water maintenance from that point on, with minimal maintenance to maintain the floor. This is a brief visual of maintaining or redoing an existing floor, a renovation of an old floor. This particular floor was quite old. Removal of tile, repair of concrete is typical for an older floor. Have to fill in divots, have to adjust, look at the different appearances of the concrete. The diamond grinding in the center panel, it gives you an indication of the type of equipment. These equipments are, again, done wet or dry, mostly dry. You'll see long hoses that are attached to vacuums to control the dust in the area. And then the final step is both an installation of the chemical hardener. In this case, you've got a ride-on scrubber. So this is a large project. Many times they're applying the chemical hardener with a smaller walk-behind scrubber where it's scrubbed, absorbed, and then washed off or rinsed off. So the flat grind and shine or flat grind and seal is a good system. The center panel, again, the near surface wear zone, is defined as just that top surface, that 1/16 to an 1/8 inch of concrete that is actually transformed and smoothed out. And that becomes your wear surface of the entire floor. Next. Okay, there is, depending on the owner's desire, you can finish concrete with polished concrete in a number of different ways to give different finishes. And we are somewhat susceptible to how the concrete is placed, and we can't change it once it's down there. So if we want to do what we call a light finish, cream finish, that would just require a few steps, fewer steps, and you can grind further. You can start with more aggressive steps where you can remove a lot of the cement paste from the top and expose more aggregate. Sometimes if the aggregate isn't placed properly or if it's an existing floor, you may not be able to get the desired effect. Sometimes you'll see in, I'm thinking in some projects on renovations primarily where you have some cutouts and things of that nature. That's also different types of concrete pours will have different effects too. So in as good as it is, there still are some aesthetical and visual differences and challenges. Functionally, they work the same. They're all durable, they're all densified, and they're all dust-proof. But from a visual standpoint, they can vary from job to job. Next. So also we can determine gloss and sheen by the number of the steps that we take at towards the end. And so these correspond with finer and finer grit levels of diamond pads, which would equate to 800 grit, 1500 grit, and 3000 grit. So they relate somewhat to the gloss reading meter, though it's hard to determine exactly a correlation, but there is a relative correlation there. Next. And then in this particular slide, we talk about dyes. There's a number of ways that we can color concrete. On new construction, we can use integrally colored concrete. We can use a dry shake-on color and then polish those two to a finish. In addition, on both new and existing concrete, we can apply acid stain or we can apply penetrating dyes and then proceed to polish the surfaces to the level that is the desired level. So with the advent of dye, we really see a big increase in the desirability of polished concrete in a lot of applications. And so we truly do find this process being considered to replace tile, carpet, other types of coatings and the like. And while it still remains very functional, it can remain very beautiful too with a little bit of attention to detail. So that concludes my part of this process. Paul, it's yours.
For my part, I just want to let everybody know that Greg and I, when it comes to the sustainable attributes of polished concrete, just published an article in the Specifier magazine in October, so just this past month that just went by. And so anything you miss in this next section, you know, it's in either more detail or you can capture it there as well. So these are the sustainable attributes that I've been working with Greg for many years now to try to get out there and to have people understand. What I hope to do by going over these is give you, you know, the green attributes, and then we'll talk in a little bit about how that may translate into assisting project teams that are seeking certification under LEED. And of course, there's more than just LEED, but LEED 2009 and then 2012 is coming up. So when it comes to the thermal mass, you know, we're finding that there's a lot of architects out there who are trying to go for these passive heating and cooling designs where they may open up a vent in the evenings and cool the slab, and then in the mornings, you know, close it and let the sunlight warm it, and those kinds of systems. And these generally help to reduce energy demand. A lot of times the actual peak energy demand, the buildings with exposed concrete surfaces can actually ride out the more expensive period of time during the day when electricity is expensive, and then have the you know, air conditioner kick in during the less expensive times of the day for the electricity. So there's a lot of benefits there under the thermal mass. The zero BOCs, there's some testing that a lot of the polished concrete manufacturers have done under some California air quality standards, some of the South Coast Air Quality Management District testing, the Rule 1113. That's all a lot of, there's a lot of information and documentation out there for that. Under regional materials, concrete itself is a regional material. The cement is typically manufactured regionally. The aggregate is harvested regionally. And then under recycled content, we have the ability to replace some of the Portland cement in concrete with fly ash, and that can help with the recycled content. Under reuse potential, we talked about how polished concrete got its start as a rehab type of installation. So there's a lot of reuse potential on renovations and additions to buildings. The green maintenance would fall more under the LEED for existing buildings, maintenance and operations program from LEED. And then durability, there's been some recent news about life cycle analysis of concrete construction between the Portland Cement Association and the MIT. They've just published a report this summer how, at least compared to steel construction, the durability and the life cycle analysis is better.
Paul, I have a quick question on
Sure.
fly ash and concrete. I've heard complaints that architects claim that the fly ash will darken the color of the concrete. Is that an issue in polished concrete?
That's a great question.
And the answer is
Have you seen that?
It could be. I think it depends on the, that's too Richard is a regional thing. Depending on the type of coal that's being used as the source for your fly ash. So it could be. And depending also on the amount of fly ash in it. Most commonly I hear the problem is more normally a finishing issue relative to concrete contractors when a high amount is being specified over 15%. Normally 15% is a level that contractors like, 30% is a level that specifiers like. So that's more of the issue, I think, than color.
Okay, thank you.
So the purpose of the next slide here was, as I was saying, there's more than just the LEED for new construction. There's the existing buildings, and then there are other rating systems out there like Green Globes. It's very well known for its life cycle analysis. It provides points for that, and the BREEAM was really the predecessor for the LEED program, started in, I believe, England, and is big in the United Kingdom. And then this Passive House that's come along on the residential side, I believe, is out of Germany, and that uses a lot of the passive heating and cooling techniques. And for anyone who's not yet convinced that green is here to stay, I believe the changes to the construction codes are are going to mandate a lot of this. And we have some details here of what's come. In California, started back in 2004 when Arnold Schwarzenegger signed an executive order to develop a green code, and it just went from voluntary to mandated in 2010. And you can see they're asking for buildings to have a 50% reduction in energy use, and also water is another issue they're trying to address. So at LEED Silver certification, you would be within the mandated code. And then the International Green Construction Code is supposed to be adopted early next year. This, if anyone was familiar with the Standard 189, the ASHRAE Standard 189 that USGBC and the illuminating engineers got together on, this incorporates a lot of that. It incorporates some of LEED, and they wanted to come up with something that was adoptable, usable, and enforceable. And they allow also for regional variances. If it makes more sense to address water conservation, say in like the southwest of the United States, they would they'd be able to beef that up. So on the energy efficiency, we talked about the thermal mass. This is what it does is it levels the heating and cooling demands throughout the day. It stores the energy from heat, and then it can release it at night. The active and some people call it passive heating and cooling, and some people call it thermally active. So there's just a little bit of language play there that I like as a writer. And why should we be concerned about energy efficiency if you weren't already concerned? Our country's buildings consume 40% of our energy and 70% of our electricity. So it's something that everyone is, at least everybody in government, is concerned about. On the indoor environmental quality that we'll get into in a little bit here, we know concrete is inert. It doesn't off-gas anything that's harmful to humans. As long as Greg, when he had that slide that kind of visualized the 3 steps to the polishing process, that middle step there, those hoses, vacuums can be attached there. So it's not just during occupancy of the building, but also during construction phase, there can be some steps taken to make sure that the indoor air quality is maintained throughout the whole process of the construction. And also he spoke about the dyes. Those dyes can be water-based. There are also acetone agents that are used. And if anybody had further questions about that, Greg is much more up on that. But they're all compliant with the Rule 1113 and also with the standard that CHIPS requires, the California Air Standard. Other areas that polished concrete can really help with is designing for daylighting. This is actually a school here in Portland, Oregon, that was one of the first net zero freestanding classroom additions in the United States. And there they came up with, actually, there's a patent pending on the device that distributes the light there. But the polished concrete, because of the shine of the polished concrete, and also the color can be changed. With the dyes, you can use a white dye, or you can use a white cement as well to keep it nice and bright in an area with polished concrete. And while we have this picture up here, I just wanted to mention about acoustics. You see this is a music area, and they were still able to use something like polished concrete, which some people may say is not necessarily, great for acoustics in the classroom, but they used that curtain that you see against the wall there whenever they really wanted to adjust the acoustic performance of the room. So there's ways to work with it in pretty much any school setting.
Paul, quick question here.
Sure.
Is the daylighting attribute due to the polish of the concrete or the light color of the concrete, or both?
It's a little bit of both. Yeah, that's a little bit of both. And as this bullet point points out here, you're able to really reduce the amount of lighting in the design and save the building owner a lot of money on the initial outlay for the lighting. And then because you have less lighting, you also are drawing less energy off the grid, less electricity.
Thanks.
So let's drill down a little bit further into some of the relevant credits. And the reason Richard and I had a talk before this about some of these credits are geared both toward the 2009 and 2012. But we're seeing I mean, obviously 2012 isn't here yet, but, you know, we're all getting ready for it, obviously. But I didn't want to leave out some of the information that I think is relevant to the past versions that are still pending certifications under LEED. So under sustainable sites, we have the heat island effect. This is something where they're looking for an SRI, I believe, of 29 to qualify for a certain percentage of the property. And what I wanted to make clear, too, before I get too far into that, is that a lot of these credits that I'm naming, you know, there's a lot of crossover when it comes to products, whether they're gonna help in this section of LEED and that section of LEED. So there's a lot of crossover. And heat island effect, I think, is one here. This is probably not, it's a very indirect type of contribution, and it would apply to any areas that may have direct, that would be on the property, because typically polished concrete is not installed outside. And Greg could clarify that if anybody has any questions. But anywhere where the polished concrete can actually reflect the sun away from the property, then you know, we're helping there with the heat island effect.
Well,
the light pollution reduction, just like we were conversely trying to add to a daylighting design, we can do the opposite and try to dull the amount of light that is produced at night in a building by keeping the colors and the gloss of the floor much lower and absorbing light. Now, the light pollution is typically more of a glazer's type of credit. So here again, this is another way indirectly that, you know, the surfaces inside the building can help with that credit, but not, a lot of that has to do with the window placement, but we're still helping there. Now, under the site master plan, this covers multiple credits within the sustainable site section. If you're able to contribute in a lot of ways as far as the building performance goes to different sustainable site credits, you can help in this site master plan credit for schools only. And one of the things they're trying to achieve with this is the you know, the reuse potential of a campus full of buildings so that the community can use it and various other ways that the site can be a community asset rather than just used only during the school day. We went through the optimized energy performance with the, this is the ASHRAE 90.1 is what they're looking for compliance for this. And what's going to happen with a concrete construction type building is that's entered into the energy modeling calculators, and so that's where you're capturing the benefits of something like a polished concrete floor or any kind of exposed concrete surfaces in the design. Did I go one or two? Okay, there we go. All right, on this one, the low emitting materials, paints and coatings, we're in the flooring, any of the indoor environmental quality. Again, polished concrete manufacturers these days have all had their products either tested for the Rule 1113, or they may have gone through one of those third-party single attribute product labeling programs such as FloorScore, and then so that covers you for the indoor environmental quality. Under the reason, and I wanted to bring up this innovation in design here. Like I said, Richard and I were talking about this section because he wanted some clarification here, and I'll be glad to give that. Before LEED 2009 came out, the USGBC put together an innovation and design credit list where they had approved project teams that had gone for an innovation and design credit, and so they were allowing the 1113 in that. So that wouldn't apply in 2009 and 2012 as an ID credit, but it would be covered definitely in the indoor environmental quality section.
Yeah, that's
so that's
Paul. Under 2009, that's a compliance option, meaning South Coast. So if you don't meet floor score, then the alternative is South Coast. So it's not innovation, it's a requirement for that credit.
good.
But I think that's the same thing you said.
Right, good. And innovation and design, again, was for rehabs and existing buildings. You could gain the green cleaning credit. Now that's in the LEED, in the normal program. It's not an ID credit. The materials minimization and recycling, this was an ID credit library type credit that was available, and the post-occupancy survey. But many of these, I think the important thing to understand here is that many of these innovation and design credits they were allowing versions of LEED ago are now either in the program or you could always go for them. So there's a whole bunch of new categories in LEED 2012, and Richard actually has a great presentation on LEED, just an overview of 2012. But we're going to try to focus a little bit more on just how they would be relevant to polished concrete. Of course, the pilot credits, which are new credits they want to put in 2012, and they're giving them a tryout right now. So even if you have a LEED 2009 project, you can go for some of these pilot credits. Under the integrative process, this is a new credit category. Location and transportation, that used to be in LEED for homes, and now it's in new construction. Energy and atmosphere, that's still available. Thermal comfort is within the integrated process. We'll go into a little bit more detail on that. The materials and resources, they've really changed that a lot. Actually, our conversation in the slide before about the compliance pass for the low-emitting materials is part of that. Indoor environmental quality as well. There's a lot more credits out there. One of the pilot credits, or these are the three that I think are most relevant to our topic today, would be the LCA, the life cycle analysis, the low-emitting interiors, and the certified products. The logos you see here, the BEES program, which I believe is the NIST, N-I-S-T, they have a life cycle calculator for project teams to use, and also the Athena Impact Estimator is something out of the Athena Institute that during the second public comment in LEED, they had actually named the Athena Impact Estimator for building assemblies, which I would include the foundation slab and all that in concrete construction. So that's an important one to have on your radar screen as polished concrete manufacturers start to develop life cycle analysis programs. You'll be wanting to know more about that as it comes up. The low-emitting interiors is another one, and then certified projects. We talked about the floor score program. That's one of several that you can use. So we talked about rehabbing of the concrete slab. There's credits for that and their location and transportation in the new 2012. Like we already talked about, the heat island reduction potential for polished concrete that can give you a solar reflective index of 29 or better. Remember ASHRAE 90.1, and remember that the energy modeling calculators will have the different building types concrete construction is what you would use for polished concrete. And then in the integrated process, they've put this from the they put this in this category this time around, I believe. And Richard, you can double check me on this if I'm off a little bit, but I believe this was an indoor environmental quality credit previously, and now it's an integrated process. And what they're looking for is, first of all, to follow the standard on the design, and then do a survey of the occupants post-occupancy.
Yeah, that's correct. They just moved the credit to a new category.
Okay.
Which you're showing there.
Yeah. And then the environmentally preferred, we probably don't have enough time to go into every single detail of each of these. And like I said, we went into a lot of depth in that specifier article, and that's kind of what brought us to wanting to do this presentation. There's a lot more detail in that article. But the environmentally preferred structure and enclosure, that's a new credit that polished concrete is going to have either a direct or indirect contribution to. Under non-structural materials transparency, another standard that you want to have on your radar screen is this ISO 14000 and the different types of product attribute reporting that's coming from the manufacturers. There's the self-reporting, which is one of the types. There's the product certification through third-party testing and some of these product labeling schemes, and then there's the life cycle analysis, which that's what they're talking about the product category rules. That's one step within an LCA. The environmentally preferred non-structural as well. There's some benefit there through installation of polished concrete, and none of the chemicals should be of any concern in polished concrete. The Proposition 65 in California is the standard there. You should be aware of. I think we pretty much covered this. They're obviously under LEED 2012. They're getting stricter in all of these, not necessarily every single category, but that's something to look out for. The performance category, if we're doing the energy modeling, the benefits of an exposed concrete surface is going to get captured there, and it will get captured again in the performance. And frankly, in the LEED for existing buildings, they'll have this category as well, and the water, use is very minimal with polished concrete, so that'll also be captured there. These are the green cleaning categories, and if I'm going too fast, you can capture these after they post it to the practice group site. These are the different ones that are relevant for the green cleaning. And many, in case you didn't know, many of the credit categories in LEED in new construction are also in the EBOM.
So the cleaning chemical or solution, is the Green Guard Green Seal certified, or is just straight water and soap for polished concrete?
It's pretty much water and soap. I know, and Greg, you can interject if you like, but I know that a lot of the polished concrete manufacturers have a concrete conditioner, which actually contains a little bit more of that densifier that he talked about. Right. So there is some periodic maintenance in that regard as well that may be necessary. You need to check with the manufacturer and look at their guidelines for maintenance for that.
Okay. And
then last but not least, how do you sell one of these to the building owner if you're on the project team and you like it? I want to point your attention all the way over to the last column on this survey that was done by the American Terrazzo and Concrete Magazine. And if you look, that blue square there, that's almost, as far as floor maintenance costs go, that's nearly $250,000 savings over 30 years. So that's one of the big benefits to building owners when they get these installed. Another important thing to put in your specifications, and Greg mentioned this earlier, we just wanted you to see there is a product label for this and a NFSI. Almost spelled that one. And then in food preparation areas, it's good to have look for manufacturers that their products carry the NSF. The the other thing is the whole building design guide has very good specification samples for green construction projects. It's very government oriented, but still they're there and they're very good. Greg mentioned before about the Concrete Polishing Association of America. Their website is concretepolishingassociation.com. So we feel that the energy efficiency can be improved with polished concrete. It's very good from a indoor environmental quality standpoint. There's a lot of use potential in new construction. It can be reused as the building type changes and renovations. It's got reuse there. The fly ash for the recycled content. It's a regional material. And then as I think polished concrete will have its day when it comes to looking at building systems from a life cycle analysis perspective. And we're already starting to see that with the MIT study that just came out in August. So that's it.
Yep, and that would be a large part of the LEED 2012 life cycle analysis. Okay, right. You caught up quickly, Paul. Are there any questions from the panel? Mark, I heard your voice in there. Do you have any comments before we go to the floor?
A couple questions, maybe for Greg. Do additives such as barrier 1 or site conditions such as the relative humidity in the concrete, the moisture content in the concrete affect the polishing?
Not appreciably, and it's one of the benefits of polished concrete is that it doesn't encapsulate moisture in the slab where you have a high vapor pressure situation. So no, it shouldn't have an effect.
Okay, no, we're seeing a lot of projects needing a barrier coat and then a drying coat for adhesive. So it's a big expense. Some of the new adhesives can take the 90% relative humidity, but not all of them. Do you find that the installers of polished concrete try to get involved with the mix design to reduce the shrinkage?
No, they don't.
Cracking?
Yeah, no, they don't. They're more concerned about flatness. And I think that that's a legitimate concern, though, as far as cracks, because you have an exposed slab there, and there is no way of hiding it. And so, other than to cover it, and that polished concrete does not cover even the colors that they apply are translucent, so you will see a transparent effect or a shading. So that's independent as far as the crack reduction.
Okay, Mark.
Thank you.
Thank you, Mark. Matt, we have a few minutes. Any questions from the audience out there?
I do have a list, so we are going to try to get through these as soon as we can here.
Yeah.
Starting back a little bit from Kevin Wood, question kind of on what we were just talking about there. Have there tests been done as to the effect color might have on the heat sink effect for the surface of concrete?
The answer is that I'm sure that the color principles apply in this case. And so, in particular, normally we are using a lighter color when we want to reflect the light, and I've seen that used most frequently as far as a conscious decision relative to color and energy consumption. And so we see the use of white concrete, white cement, shake-ons, light-colored concrete and then polished concrete in order to reduce the amount of energy used to light a surface in conjunction with daylighting. But I would think conversely, if they wanted to absorb light and absorb solar heat, that darker colors would apply in this case.
All righty. Next question as we go through these here from Francis. wondering how does one deal with the dust while grinding and polishing? Does the process for polishing and grinding release toxins such as fly ash and slag bound to be in cement into the air, and are there any health hazards related to that issue?
Good question.
Let me answer that, and I'll tell you that there's a couple ways that we do this. There are very effective vacuum systems that are used to draw airborne dust out of the air during the grinding process. Of course, somebody could avoid not using one, and it would be very dusty, but they're effective, and a good contractor or a qualified contractor would have that type of equipment. Also, most of your dust is done, created at the coarser grinds, as you can imagine. And so in some cases, the contractor may grind the first couple of grinds wet, and so then pick up the slurry and properly dispose of the slurry in that manner and proceed with a dry grind through the rest of the steps. These steps, by the way, there may be 6 or 7 steps involved in preparing a concrete slab or in that neighborhood. So a last question about the items of dust and hazardous to the owner. Not particularly. I think anytime it's more of an irritant than a situation of there isn't a silicosis effect, for example, or something of that nature. Though certainly in some conditions I could imagine that it could be very irritating to the contractor. And then lastly, if they're doing a renovation, it's important that we want to try to maintain the building from a lot of dust. And so again, the use of a good strong vacuum, etc., can be used.
And I'll add to that, to reinforce those hazards, it could be included in the construction IAQ management plan. Okay, Matt, we probably have enough time for one more.
Do you know how to calculate the positive attributes of the thermal mass in daylight reflectivity? Is there a calculator website, or is there a tool that you recommend or that you know of for individuals to be able to analyze and determine that attribute of thermal mass in daylight reflectivity?
I'm sure there is. Greg, can you name them offhand?
Well, you know, the Department of Energy calculator for energy modeling, like I said in the presentation about once you enter the building type, depending on how many, you know, and I've asked this question for years, and I think as energy modeling calculators become better at picking up the different systems and you know, exposed concrete as a floor surface, for example, then, you know, like I said, polished concrete will have its day. It'll come out as a really good.
Yeah, and also, Paul, when we're talking about polished concrete, in many cases we're using it in conjunction with some type of a internal heating or cooling system too. So the benefit of the bare concrete, of course, is to allow that heat that's generated from internally or externally to be retained in that heat sink or that cool sink, depending on how it works. So it's used together with other systems, so that should not be discounted.
Yeah. And then on the you know, the reflectivity, there's meters that calculate excuse me, the solar reflective index. So those are what you need there.
Okay, we're out of time here. Do you want to any closing remarks, Paul or Greg, before we sign off?
No, I think thank you very much for allowing us to give our presentation.
Okay, and thank you, Greg, for joining us as well.
My pleasure.
And our audience out there. And at this point, we're going to sign off, and we'll see you next month.